Adding the first 5 terms or 8 terms of a sequence is not very difficult, since we can just write the terms and add them together. But what happens when we have to find the sum of the first 25 or sum of the first 100 terms of a sequence? We can't possibly write down all of them and then add them together. So there has to be a formula, and if you want to learn about it, jump straight into the video right now. Hey guys, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success. Exponent to Success is an initiative which is committed towards adding an exponent to your learning curve. If this is the first time that you are coming here, or if you are a first time visitor, I would suggest you subscribe to our channel right now, and do not forget to click on the bell notification also, because then you won't be missing out on any future content from us. In the previous video we discussed how to find the nth term of a series, and if you haven't seen that video yet, just click on the top right corner of the screen and that link will take you to the previous video. This video is about finding the sum of first n terms of an arithmetic progression or an arithmetic sequence or an arithmetic series, whatever you may call it. We'll of course find the formula for it. We'll try and understand what the general formula is, but before we go into that, let us take a very simple series. Let's take a finite series which has only 5 terms: 2, 4, 6, 8 and 10. So this is the series that we have, or the sequence that we have, and we want to find the sum of all these terms of the sequence. Now before I go into that, let me calculate the sum manually so that we know what the sum is, and then come and maybe possibly find a general formula for it. So what is 2 plus 4? 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20 and 20 plus 10 is 30. So we know that the sum of the first 5 terms of this series is 30. What are the other ways of finding the sum? So let me write it as that the sum of the 5 terms of this series S5, let me denote it by the letter S5, is 2 plus 4 plus 6 plus 8 plus 10. Since we are going to find the sum of this series, we can write the numbers in any order that we want, because 2 plus 4 is also 6 and 4 plus 2 is also 6. So let me write the numbers in reverse order, where I write 10 plus 8 plus 6 plus 4 plus 2. And do you agree that the sum that we find out from the first equation on top will be the same as the second equation on the bottom? Yes, the sum will be the same because they contain the same numbers and we are adding them all together. So how about adding these two equations up and see what we get? So if we add these two equations, it becomes 2 times the sum of the 5 terms, which will be equal to 10 plus 2 is 12, 8 plus 4 is also 12, 6 plus 6 is also 12, 8 plus 4 is also 12, and 10 plus 2 is also 12. Wow. So that means 2 times the sum of 5 terms will be equal to 5 times the sum of the terms, which is the sum of the first and last term, which is 12, right? And the sum of the second last and the second term is also 12. The sum of the third last and the third term is also 12. So which is the same as the sum of the first and last terms. And what was 5? 5 was, well, it is the number of terms. So isn't the sum of 2 times the sum of 5 terms the same as the number of terms multiplied by the sum of the first term, well, let us call that A1, and the fifth term, which is A5, right? Then what will be the sum of 5 terms. This is 2 times the sum of 5 terms. So dividing both sides of the equation by 2, I get 5 over 2 multiplied by the sum of the first term and the last term. How much does that equal to? So let's see, sum of 5 terms is equal to 5 over 2, which is 2.5, multiplied by the first term, which is 2, plus the last term, which is 10. So that gives me 2.5 multiplied by 12, and that indeed is 30. So 30, the sum of the 5 terms, is the same as we have got here. Let us take another simple series and remember this formula that we have. So this time we are going to take 8 numbers and see if we are correct in finding the sum. So let me remove all this, since we don't need any of these now. What I need is only the formula that we have. And I'll modify the formula here a little, because now we want to find the sum of the 8 terms, first 8 terms. So we've got 5 terms here. Let's continue with the same series. So how about taking 12, 14 and 16? That should be 8 terms. Okay, what I'm going to do is I'm going to modify parts of this equation that we have. So it is not sum of 5, it's sum of 8. The total number of terms is 8, and instead of a5 we'll take a8 now. So sum of 8 terms will be the number of terms, which is 8, multiplied by the sum of the first term and the 8th term. And let us see, 8 over 2 is 4. So it will be 4 times the sum of the first term, which is 2, plus the 8th term, which is 16, which means 4 times 18, or that should give us 72. Now let us see if that is correct. So we know that the sum up to 10 was 30. So 30 plus 12 is 42, 42 plus 14 is 56, and 56 plus 16 is 72. Yes, that indeed is correct, which means that this formula that we have is correct. So in simple terms, the formula for finding the sum of any n terms of over 2 multiplied by the sum of the first term and the last term. So that should be the formula. Well, we can derive the same formula in a different way also. So we know that any arithmetic progression is in the general form is a, which is the first term, a plus d is the second term, a plus 2d is the third term, a plus 3d is the fourth term, and so on. And it continues up to the last term, which we know that the nth term of any arithmetic progression is a plus n minus 1 times d. So if we want to find the sum of the first n terms of any arithmetic progression, it would be a plus d plus a plus 2d plus and so on up to a plus n minus 1 times d. And if we write them in the reverse order, it will be a plus n minus 1 times d plus a plus n minus 2 times d plus a plus n minus 3 times d, and so on till we come to the first term, which is a. And if you add them together, so a, the sum of this would be a plus n minus 1 times d plus this, by the previous example we know it's the same as a plus n minus 1 times d, and so on, and the sum of the last term also would be, sum of the last two terms would also be a plus n minus 1 times d. So we've got this repetition, which is 2a plus n minus 1 times d. And how many times are we repeating it? 1, 2, 3, 4, and it keeps going on till we reach the n term. Thus we can say that if we add them all together, the 2 times the sum of n would be equal to n times 2a plus n minus 1 times d, or simplifying that, dividing both sides of the equation by 2, we can say that the sum of n terms of any series is n over 2 times 2a plus n minus 1 times d. Now you would say that we should get the same formula. We found the formula earlier as something else and this as something else. The earlier formula, if we see, was n over 2 times a1 plus an, which is the first term and the last term. Here we are getting something different. Well, we can always write it again as n over 2 times a plus n minus 1 times d. And you know that a plus n minus 1 times d is nothing but the last term, and a is nothing but the first term. So we get the same thing, that it's n over 2 multiplied by the sum of the first term and the last term. So that's the formula. Let's try and solve some questions on it. So we've got this question that the arithmetic progression that we have is 5, 15, 25 and so on, and we have to find the sum of the first 20 terms of the arithmetic progression. Now here we do not know what the 20th term is. So we've got two formulas. We had n, that sum of n terms is n over 2 times a1 plus an, and the second formula that we had arrived at was n over 2 times 2a plus n minus 1 times d. So we can do this in any way we want. So the first way, we know that this is an arithmetic progression and we just need to find the difference between the second term and the first term, which is 10. To verify that, we can also do the difference between the third term and the second term, which is 25 minus 15, which is again 10. So we know that d is equal to 10 and the first term a is equal to 5. So let's find the sum of the first 20 terms. So s of 20 would be 20 terms, so it will be 20 over 2 multiplied by 2 times a, so which means 2 times 5, plus n minus 1. So n minus 1, since n is 20, so 20 minus 1 times d is 10. The common difference is 10. Let me put these in curly brackets so that to avoid any confusion. So let me simplify this further. So 20 over 2 is 10. That is being multiplied by 2 times 5 is 10, plus 20 times 1 is 20 minus 1 is 19 multiplied by 10. So that gives me 10 times 10 plus 19 times 10 is 190. 190 plus 10 is 200. So it becomes 10 times 200 or 2000. So the sum of n terms of this series should be 2000. We can find the same using the other formula also, but the only problem in this formula is that we do not know what is the last term of the series or what the 20th term of that series is. But we can find out what the 20th term is, because we know that if we want to find out the 20th term, it would be nothing but the first term a plus n minus 1 times d, right? And a in this case is 5 plus n minus 1, so the 20 minus 1 is 19, times d is the common difference we know is 10, so 19 times 10, or 5 plus 190. So that means it should be 195. That's the 20th term. And once we find that, we can put this value back into this formula and find the sum of 20 terms, where s of 20 should be equal to 20 over 2 times the term, which is 5, plus the 20th term, which we found out was 195. 2 over 20 is 10, so it becomes 10 times 5 plus 195 is 200, and that gives us 2000. And you see how this and these both are equal. So no matter which formula we use, we will arrive at the same sum. In some cases we will have to find the 20th term, or whatever the number of terms is given, or maybe the last term, we have to find that out, or in some cases we can just apply this general rule and find out what is the sum. So let's take one more question and try and figure out what the sum would be. So the next question that we have is 10. We have got an arithmetic progression which is 10 plus 12 plus, and keep going up to the number 100, and we have to find the sum of all these numbers. Well, what we know here, let us find that out first. What we know here is a, which is the first term, which is 10. We know that the common difference between any of the two terms is 2, so d is equal to 2. We know that 100 is the last term of the sequence, but we don't know what number term it is. So since the formula for finding the sum of n terms is n over 2 times a1 plus an. In this case we have a1 also, we have an also. What we don't know is the number of terms, but we know that the last term is 100. So let us put that. We also know that the nth term of any number is a plus n minus 1 times d, and we know that an in this case is 100, so we just need to find out the value of n. A has a value of 10 plus n minus 1 times d, and d in this case is 2. So I'll subtract 10 from both sides of the equation, so I get 90 is equal to n minus 1 times 2. I divide both sides by 2. The 2 and 2 get cancelled over here, and I get n minus 1 is equal to, for 90 divided by 2 gives me 45. Or adding 1 to both sides of the equation, I get n is equal to 45 plus 1, which is 46. Now we know that there are 46 terms now, so we can say, so n is equal to 46. Let's write that also down. So we know that sum of n terms of any series is n over 2 times the first term plus the last term, which in this case we know is 46 is the number of terms, divided by 2 times first term is 10 plus the last term is 100. So it becomes 23 times 110, or it becomes 2530. That is the sum of the first n terms, or the first 46 terms of this series, where the first term is 10 and the 46th term is 100. So that is how we find out the sum of n, the first n terms of an arithmetic progression. And of course we can't find out the sum of and a progression which is infinite in nature. For example, you can't find the sum of all natural numbers, because the natural numbers start from 1, 2, 3, 4, and they keep going on till infinity. Once you reach infinity, there is one more number after the infinity. So the sum of an infinite arithmetic progression does not exist. It will keep going on and on. But we can find the partial sum or the sum of first 20 terms. So sum of first 20 terms or sum of first 50 terms, or which we also call as the partial sum of an infinite arithmetic progression, or we can find the sum of an finite arithmetic progression. So whatever the case is, I think it's pretty easy. Once we have these formulas in mind, we can find the sum of or the partial sum of any arithmetic sequence. What are your comments about the video? I would like to hear all about what you feel about the video. So just drop down into the comment section below and leave a comment for me, and I'll definitely get back and reply to you. And if you have learned something out of the video, why not share it with your friends also, so that they also can benefit something out of the content that we have. And like I told you, if you haven't subscribed to our channel as yet, this is the right time to subscribe to our channel. Just click on the subscribe button given here, and you can watch these videos which are given on the left side, and they'll be good learning for you. And do like the video here, and also share the video with your friends. Take care. God bless.